Welcome again. Today we are going to solve many problems by using the formula which I told in the previous lectures. Let's solve some more questions of the Amdahl's law. The first question is, we are considering an enhancement to the processor of a server. The new CPU 10 times faster. 10 times faster means the speed of enhancement is 10. IO bound, input output bound server 60 times waiting for IO. 60% time waiting for the IO. I told you fractional enhancement means how much time or how percent of time the processor is busy doing tasks, not the waiting time. It means 60% time waiting means 40% time they are doing the tasks. So our fractional enhancement is 40%, not all 60%. That is 40% means 0.4. The same I told you formula is speed up is equals to 1 by 1 minus Fe plus Fe by Se. Then by getting the value we can simply get the answer. Let's solve another questions. Suppose we are considering an enhancement that runs 10 times faster. 10 times faster means simply speed of enhancement is 10 than the original machine, but it is usable only 40% of the time. It means 40% of time the processor is doing the task. It means 40% is our fractional enhancement. That is Fe is 0.4. What is the overall speed up after enhancement? That is speed up is equals to same formula 1 by 1 minus Fe plus Fe by Se. By putting the value we can get 1.56 as the answer. Let's solve another question. We are considering an enhancement to the processor of a server. Our new CPU is 20 times faster. Simple speed of enhancement is 20 on search queries than the old processor. The old processor is busy with search queries 70% of the time. Simply 70% of the time is busy. It means 70% is our fractional enhancement. That is 0.7. And the fractional speed enhancement is 20. What is the overall speed up of gain by integrating the enhanced CPU? It's very simple. That is only one formula 1 by 1 minus Fe plus Fe by Se. And put the value, you can get the answer. Let's solve one more example. And in this question, we are using the another formula. Let's take 95% of the program execution time occurs inside a loop. Okay, that can be executed in the parallel and rest 5% in the serial. When the question is talking about the parallel and the serial computer, then we use the second formula that I taught in the previous lecture. That is this formula. Speed up is equals to 1 by F plus 1 minus F by P. I told you P means number of processor and F means serial computer. And in these questions, there is a question of serial and the parallel. So we have to use the formula speed up is equals to 1 by F plus 1 minus F by P. Let's solve these questions. 5% serial, it means F is equals to 5%, that is 0.05. And this is what is the maximum speed up we should expect from the parallel version of a program executing on 8 CPU. It means number of the processor is 8 and is equals to what? 8. Let's solve formula speed up is equals to, what is the formula? 1 by F plus 1 minus F by P, where P is the number of processor and F means serial computer. 1 by 0.05, 1 minus 0.05, P means 8. By solving this, we get 5.95. Sometimes in the question there is only given parallel computer, and we know that 1 minus F means parallel computer. Example, in this question 95% of the program execution time occurs inside a loop that can be executed in parallel. It means 95% is doing in the parallel task. If in the question this 5% is in serial is not given, then by common sense we can assume that if the 95% of the program is in parallel, then obvious 5% is in the serial. So we can sometimes see the question and assume by taking the assumption how much time is serial. I am to say that how much is serial. Okay, let's solve another question. In the Amdahl's law, the question is a little bit lengthy, but the solution is very easy. So let's solve the questions. The first question is, a common transformation required in graphics processor is a square root. Implementation of floating point square root varies significantly in performance, especially among processors designed for graphics. Suppose FP square root responsible for 20%. Here is the two. One is FP square root and one is only FP. Let's solve the questions. Okay. Suppose fp square root responsible for 20% of the execution time. It means for the fq square root, 20% is the fractional enhancement. That is, for fp square root, fe is 20%, it is 0.2, okay, of a critical graphic benchmarks. One proposal is enhanced for fk square root hardware and speed of this operation by factor of 10. It means the speed of is increased by 10%. It means speed of enhancement is 10 for the fq square root. The other alternatives is just to try to make all fp, okay, instruction in the graphic processor runs faster by factor 1.6. It means the alternative, which is alternative, that is fp is another alternative of the fq sqrt, which is 1.6 in the speed enhancement. And fp instructions are responsible for half of the execution. It means 50% of the executions is responsible by the fp. It means fe is 0.5. The question is compare these two design and find out which is better. Please. For the fq square root, we know fe is 20%, means 0.2, and se is 10. By the simple formula 1 minus fe by se, we get 1.21. And for the fp, fe plus 0.5, se is 1.6, which is given in the questions. The speed up is equals to 1 minus fe plus fe by se. 1.21, 1.23. We know the more speed up means good.